Hi everyone, I'm Dominik. I'm a developer evangelist for a company called Twilio. Twilio is a cloud communications platform that allows you to add easily voice, SMS, video, or similar to your applications. But today I'm talking about none of that. Instead, I'll be talking about hackers. Essentially people like this guy who probably is just watching the Matrix movies using sunglasses in the dark, and a hoodie in a dark room. And obviously this well-dressed hacker that knows that style is just as important as staying anonymous while hacking. And last but not least, Hacker Man, the only person known to man that can actually hack you back in time. I could probably fill up the whole talk just with slides of ridiculous hacker pictures, but the actual title of the talk is 2FA WTF. And as many of you might have guessed or read in the abstract, 2FA actually stands for Two Factor Authentication. So it's a bit dark here, but let's still do this. Quick show of hands, how many of you know what two-factor authentication is? All right, and now keep your hands up if you actually use it on a daily basis. All right, everyone who has their hand down now, I must say I'm very sorry because hackers might be attacking you right now. And this is the only way I can imagine they're doing that. All right, joke aside, what is two-factor authentication actually? So two-factor authentication is a security process that requires the user to provide two forms of identification. So that's usually, and these forms of identification need to be different. So that's typically something that you know, and that's something that you have. So a basic example that I think all of you are using is your bank account. So when you try to withdraw money, the first thing that you need is your bank card, which is something that you have. And the second thing is your PIN, which is something that you know. There's also a category of something that you are, which is biometrics, but not only is it very hard to implement, but in the case of things like fingerprints, it has been proven that it's first of all easy fakeable, and second, those are essentially 10 passwords that you can't revoke, right? Like you only have 10. If someone got hold of that, that's the end. So why all of this anyways? We got passwords, they're supposed to protect our users and ourselves. Well, unfortunately, passwords alone are weak. And to highlight that, let's look at two famous examples from recent years where password protection alone has failed. And the first example is Mark Zuckerberg. He recently got hacked on both his Twitter and Pinterest profiles after his credentials showed up in the data of a 2012 LinkedIn hack. And in my opinion, that was actually pretty late because the hackers afterwards revealed his password, and his password was on all of these three services, ... And I think this is an important story because this person is not only a normal user of the web, but he wrote the first version of Facebook, which I think most of us are using, and he's the CEO of the said company now. And especially he should know that using a simple password across multiple services is dangerous. And this brings me to my first point, and that's users are bad with passwords. I'm fairly certain everyone at one point wrote a sticky note at one point with a password and put it next to the PC. And to highlight this more, let's look at the top 10 passwords from 2015. And this is based on 2 million leaked passwords, and as you can see, more than half of them are enumerations from 1 to anything between 4 and 6. I don't know why 6, between 4 and 9. I don't know why 6 is the most popular one, but it seems like that. And also, obviously, our favorite password and QWERTY are among them. But the important part here is that those are just the top 10, and there were 2 million leaked passwords that this was composed out of. And the hackers are aware of this data, so they use this to actually coordinate brute force attacks or similar things. But not only users are bad with passwords, other websites are bad with passwords too. This data that the hackers used to attack Mark Zuckerberg came from a LinkedIn hack. And LinkedIn just got acquired for $26 billion from Microsoft. And they weren't able to store passwords safely 4 years ago. So I'm kind of scared about other big services not being able to store their passwords safely. But you might be, well, I should be safe because I follow rules, like I use complicated passwords and I use individual ones for everything, and I use a password manager to keep track of all of that. In that case, let me introduce it to another person, and that is Matt Honan. Matt Honan is a tech journalist that got hacked in 2012 and practically got his whole digital life destroyed. And this hack is not related at all to the LinkedIn hack, in case you're wondering about that. In fact, the hackers afterwards revealed to Honan how the hack worked in exchange for not pressing charges. And we can use this information now to actually look at what the hackers exactly did and put together a timeline. So the first thing that the hackers did is they did something very normal. They went to his personal website and they found his Gmail address, which is something that I think most of us do. If we have a personal website, we put our personal email there. And based on that, they took this information and went to the Gmail recovery tool. They entered his email address and they found out that he had an alternative backup email address on file. And that was a me.com email address from Apple. They did one more thing with his website, and that's they used Whois to look up the address that was associated with the domain. And this is a spoiler. This was the most technical part of the whole hack. All right. Afterwards, they called Amazon and tried to add a new credit card to Honan's account. And after failing all of the security questions that they had, it drilled down to 3 basic questions, and they were his name, his email address, and his billing address, which, thanks to his website, they all 3 had now. So after they were able to add a credit card, you might think that's great because Honan can go shopping on the cost of the hackers now. But what the hackers did is they hung up the phone and they picked it right up again and called Amazon again. And they were like, hey, I would like to reset the password to my account. And Amazon only required one piece of information, and that was the last 4 digits of the credit card that was on file, which they just put on file. So after that, they were then able to log into his Amazon account, and surprised, they were able to get the actual 4 digits of his credit card because Amazon displays them in clear text, so they were good. So at this point, they were under full control of his Amazon account. And they could have probably stopped there because, I mean, they can go shopping on his card. That's pretty good. But what they actually wanted to achieve was a completely different goal. And Amazon was merely a tool for what would come next and where we have actual concrete times. Because at 4:33 p.m., they then called Apple. And they tried to recover the iCloud access, and the only 2 pieces of information that they needed were his billing address and the last 4 digits of his credit card that they had now thanks to Amazon. After going through all of that process, they were then able to fully reset his password to of his iCloud account. And since they were under control of that email now, they could also reset his Gmail password. They didn't leave it there. They used the iCloud access and this great remote delete feature to wipe his iPad and his iPhone, and also reset his Twitter password. Just 3 minutes after that, they made sure to be completely clean by also wiping his MacBook. And just 5:12, so merely 45 minutes after at least the events that we know when they happened, they tweeted on his Twitter handle taking credit for all the hack. So you might thinking, why all of this? Why going through so much hassle? Was it something personal that they didn't like an article that he wrote? And it drilled down actually to 3 simple characters, and they were MAT, and that's his Twitter handle. If you are on Twitter, you know how hard it is to get one of those short Twitter handles. The hackers were really mad at him for having such a short Twitter handle, so they decided to take revenge and actually hack him. And this whole story gets me to my next point, and that's social engineering works. At none of this point, the hackers were doing anything really technical. It was all about social engineering. You don't have to be a programmer to pull this kind of hack off. So there were no brute force attacks, there were no data leaks. This was purely done through social engineering. And the worst part about that is at any point in time, two-factor authentication could have stopped this attack. So as we've seen, passwords alone are weak. So how do we fix this problem? The solution is to add a physical protection layer to our digital world. Because when a person tries to break into your house, they need to go to your house and then try to pick the lock. Thanks to the internet, hackers can attack you from anywhere. So if we add a physical protection layer, we make it harder for the hackers to attack us and better protect ourselves. And I'm not talking about anything complicated, such as this weird handshake, even though it would be pretty amazing if we could do that. So how else can we do it? There are actually quite a few options that we can pick from, and I'm going to walk through them. But before we do that, let's take a quick look at the typical user flow without two-factor authentication. So when a user typically visits your site, the first thing that they do is they go to the registration page. And there they need to come up with a username and a password. They might have to provide additional information, but these are the core pieces that you need. And then the user is logged in, easy as that. So when they return, they go to some sort of login page, and they provide what they remember was their username and password. And once the system verified these details that were on file, the user is then logged in, assuming that everything worked well. So how can we augment this process to add two-factor authentication? The first option is phone two-factor auth. So using standard means such as SMS or voice to augment the flow. And this can be anything, and most typically it's SMS, but it can be also voice just as easily. So if we go through the process, you can at any point replace SMS by voice, and it works the same way. So what do we actually have to do? The user goes again to the registration page, and this time, aside of a username and a password, they actually provide a phone number as well. And once they did that, the system actually now has to verify this phone number because it's vital information. So this is typically done through a text message using something like Twilio to your phone to verify that your phone that this is the actual phone number. Once that is done, the user is then successfully logged in. So when the user returns, it starts very similar. They go to the login page and they enter their username and the password. If that is correct, the system then sends a verification code via SMS or via phone to the user, and the user has to take this code and enter it back on their site. The system then has to take the code and verify it, and once that worked, the user is logged in. So what are the pros and cons of this? The biggest pro here is clearly that this works for everyone. No matter whether you have a feature phone or a smartphone, everyone can receive SMS. It doesn't matter whether you have a BlackBerry and Android. If you need to install an app or anything, you can receive SMS. And even if you can't, phone will still work because you're gonna have somewhere a landline, or you're gonna have a Google Voice account or anything that can receive phone calls. To the cons, obviously it costs money because you need to send an SMS or do a voice call, and those providers aren't cheap. The second thing is it requires a signal. So if you're in a basement or if you're in a venue like this and your two-factor authentication works through phone, that might mean that you can't log into your account even though we have Wi-Fi around. One question you might have now is that if phones are a physical protection layer, and that's great, why not just get rid of passwords if users are so bad and just use the phone? I mean, that's what Twitter tries with digits and other solutions. Well, in that case, let me introduce you to D. Ray McCason. He's an American civil rights activist who recently got hacked on his Twitter account because he had two-factor authentication enabled. And what happened was he had, the hackers somehow found out about the last 4 digits of his social security number and then phoned up his phone provider, Verizon, to ask to reconnect the SIM card that was associated with a phone number to a different SIM card. Once they did that, they were under full control of his phone number, and they used the fact that Twitter, once two-factor authentication is enabled, only requires a message that is sent to your phone number to actually reset the password. So since they had access to the phone number, they were able to reset his password. And I know this is a rather elaborate attack because finding the 4 digits of a social security number should in most cases not be easy. But this highlights that just relying on phone isn't enough as well. If Twitter would have used two-factor authentication for resetting passwords like they do for the login, D-Ray would have been protected. So, and the bottom line is always use 2 factors. Just using the second factor isn't 2 factor, it's 1 factor. So let's talk about the next option, and that's one-time passwords. So those are the codes that are typically generated through apps like Google Authenticator. And the flow for that, again, starts with the user going to the registration page and entering a username and a password. In this case, no phone number is required. And then the system, or your system, has to generate some sort of secret and then share the secret with the user. And after that, once that happened, the user is logged in. So what happens when the user returns? They go to the login page and punch in the username and the password. The system verifies this. And if everything worked out, the user has to open an authenticator app, such as Google Authenticator, and then take the code that is on the phone and copy it over to the site. So the system then takes this code and verifies it against the secret. And once that happened, the user is then successfully logged in. Let's talk about those secret-based codes. These codes, the great thing about them is you don't have to come up with them yourself. Whenever you see those like 6-digit codes, you might be wondering, is it just a random or something? They're actually based on well-defined crypto algorithms that have been around for years. And specifically, they're called HOTP and TOTP. So HOTP is the HMAC-based one-time password, and TOTP is the time-based one-time password, which is essentially HOTP, with the difference that it's based on the time since the Unix epoch. And if you were wondering how this formula looks like, which I'm not sure if you were, this is the formula. It's late. It's been a long day. I think beer's waiting after this talk, so I'm not going to walk through this. But if you were wondering what this means, there's a great GitHub repository that is a Node.js implementation of the said algorithms that is slightly better to understand and easy to walk through. In fact, I'm going to use this now to quickly show you how to generate these tokens. Since we're at a Java conference, there are similar examples for Java and other languages. So it's a fairly basic algorithm. So let me jump into the Node REPL. And the first thing that I'm going to do is I'm going to require the NOTP library. And then I'm just going to shorthand the different functions. So TOTP is NOTP.TOTP. Cool. So now that we have that, let's talk about HOTP. So for HOTP, we need to provide two pieces of information. The first one is a secret that we generated for the user. So that would be something like my super secret. Don't do this. Generate something weird. And then what we need to pass in is a counter. So HOTP is based on a counter. And I'm going to just start with 0. And then we get a code. And that's a 6-digit code like we wanted it. So as you can see, whenever I run the function, I get the very same code. But if I change the counter, I get a different code. Every time that I increment this counter, I get a different code. So if we want to verify this, it goes pretty much the other way around. So what we need to do is we need to provide the code, 524. We need to provide the secret again. And then we need to provide the counter that we want to check for. So this will be the counter that you're keeping track on your server, that this should be the one that the user tried to authenticate with. And then we get a delta 0. So this means that this was exactly spot on the code that we're looking for. So if we change the counter, you'll see that we get a different delta. And this is less important for HOTP, but this is getting very important for TOTP. Because if we look at TOTP, the counter is essentially the time since the Unix epoch divided by, it's usually 30 seconds. So that means that if we generate a token, the only piece of information that we need to provide is the secret, and that's it, and we get a token. So if I execute this multiple times, you see that I get the same code. If I wait a bit, at one point, once this 30-second window elapsed, this code should change. I bet when I try to verify this now, I will actually fail. So let's see. So again, we don't need to provide the counter because the counter is based on the system. And now we get a delta -1. That means, yep, the code changed. So, and there you can see why the delta is great, because that means that if your user tries to punch in the code from their app and they're like in the last 1 or 2 seconds, which at least for me happens all the time, and this has to go to the server, by that time the time window expired. So if you want to do a good implementation and a good user experience, give this user a sliding window of 30 seconds or a minute, because it can be sometimes very painful. All right. The other thing you might be wondering about, if TOTP doesn't have to keep track of a counter, why use HOTP at all? And HOTP is great if you want to provide a large batch of secrets at once to the user that they can use over time. So, for example, if a bank wants to provide a set of codes that are offline that they can print, that you can print out, you can use HOTP for that, and then you just need in your system keep track of the secret and the counter. And not like a whole database of the codes for every user and which ones have been used and which ones haven't. All right, so let's go back to the slides. Cool. So now that we've seen how the generation of these codes work, there's one more problem, and that's sharing the secret. Because ideally, it's not my super secret, but it should be something more complicated, something obscure that you can't remember and that is hard to type. And the solution that is used in the industry most often is QR codes. In fact, the pattern that you see in the middle, wrong key. This pattern is the one that Google Authenticator understands and that most other apps by now understand as well. So what you need to do is you need to essentially construct a URI that contains the type that should be used to generate these codes, which is HOTP or TOTP, and then pass in the label so that the application can nicely show which account this is related to the code on your that is generated, and then pass in some parameters. And these parameters are things such as the secret or the issuer that is handing out this secret. And then if you convert that into a QR code, the Google Authenticator app will be able to scan this. All right, let's talk about pros and cons. Obviously, there are pros and cons to this as well. The biggest pro is it works offline. Once you shared the secret, you're good. Like, you don't need data connection, you don't need phone connection, you don't need anything because your device autonomously generates these codes. And cons, you need to either build your own app, like the way Facebook did, or you need to use and rely on an app such as Google Authenticator, and in the case of Google Authenticator, that hasn't been updated for ages. So I'm not sure if that's the one you want to rely on. So the question is, can it be better? And you might know the following sentence, and that's friends don't let friends write their own authentication frameworks. Because the best way to handle security is if you let people that know about security actually deal with it. And in the case of, I'm a Node.js developer, so I would use Passport, but there is, I think, Spring Security and a project from Apache. So there are like a lot of authentication frameworks for pretty much every language. And I would like to introduce you to a similar concept. And that's friends don't let friends write their own two-factor authentication frameworks. Because just like you don't want to deal with properly salting your hashes and taking care of everything is safe, you don't want to deal with things such as code generation, and you don't want to store secrets yourself. So let me actually tell you about an option to achieve that. And that's Authy. Authy is a company that Twilio acquired in 2015 that handles two-factor authentication for you by providing an easy set of APIs that you can use. And with respect to the user flow, it's very intuitive. The user goes to the registration page and enters a username, password, and a phone number. And this phone number is important for Authy because the system then uses this information to register the user with Authy. And no, you don't have to pass the password, but the phone number is very important. And Authy will return you an ID. So this ID is the one that you can use throughout the time. So if your user changed the phone numbers, your ID is still the same. And afterwards, the user is logged in. So when the user returns, they go to the login page and enter their username and a password. And your system still needs to handle the first factor authentication because we only do the second factor. So you still need to verify the username and the password, and if it's correct, then you use the ID of the user to use Authy to prompt for authentication. And then the user takes the app verification code, which is sent through SMS or using an app. And then after that, the system uses the Authy API to verify this code. If all of that worked, the user is logged in and we're happy. All right. So let's quickly talk about user experience. So far, all of these approaches that we covered somehow require the user to take a phone, look at it, look at the screen, look at the phone, look at the screen, and type in the code. And in the case of one-time passwords, type it in as fast as possible. This is a horrible user experience, and it's especially bad if you're on a phone and you're trying to log into a site and you're constantly switching tabs. So the question is, can it be better? And I would like to show you one more option that not only improves the user experience significantly, but is also maintains the security and makes it even better. And that's push notifications. Or in Authy, they're called OneTouch. And rather than actually going through the same steps again, let me actually show you how this works. So what I did is I basically cloned our demo example that I'm going to show you where to get this afterwards. And what I'm going to do is I also have my phone here connected. And I already have the Authy app, but if we look at the Authy app, it's empty. I don't have any accounts added to it. So the first thing that I do is I go and sign up to my site, which can be your site. And I pass in an email, and I pass in a super secret password, and then I pass in my phone number. So I take the prefix, and then the number, and I sign up. And now you should see I get a push notification here. So if we open that, boom, we already have the token generation. So that means I did not scan any QR code or something, right? Like I can sit in a cafe now and nobody can like scan over my shoulder and snap a picture of my QR code. And what I can do now is when I go and log in again, I go and I type in my stuff and I type in my password, and let's first do the experience without OneTouch. So what happens then is it asks me for the verification code. So luckily my phone is now on the other side of the screen, so this goes fairly well. I don't need to look back and forth between my phone, and then I'm logged in. So if I log out again, and let me close this because the effect is better, and then I log in again once more. And now I use OneTouch. What you will see is there should be a push notification. And if I click on it, you see it says that I tried to request to log into the app. It provides my email address and the date that this happened. But you can add way more information to this. So you're not limited there. You can add as much information as you want, and you can use this for transactional things as well. So if you're writing a banking app and you want to use push notifications as a confirmation for the user, and you want to specify the amount and the account it goes to and things like that, you can add that. If you want to have a different logo for every request, you can do this. I decide I want to log in, so I click approve. And now my site should get back the callback. Yeah, and I'm logged in. So what happens under the hood is that for the push notifications, I set up a callback, so a webhook essentially. I set up a webhook to be pinged every time there was an approval notification. And then I take that to notify the UI to, hey, actually grant this person access. And the other great thing is if I reload this now, I actually have the user here. So if I want to stop granting this person access, or if I want to say, don't allow SMS notifications about this anymore, we can do that. And the other thing is, we can fall back to the other thing. So the original demo that you can find in our tutorials in various languages, so on twilio.com/doc/tutorials, there will be different languages, and all of these are the same demo. But what they do is they automatically try OneTouch. If that fails, they fall back to tokens. If that fails, they fall back to SMS. So I just added this basic hook so I can force it to do the token generation. All right, so yeah, the cool thing about those, they're tutorials, so you can either walk through them. So this is a Java one, or you can just go and see the code on GitHub if you're interested in that. And you can just download that. All right. Cool. Let's go back to the slides. Wait. All right. So now that we've seen how Authy works, obviously there are pros and cons to this approach as well. The biggest pro here is you don't have to implement this yourself. You don't need to develop your own app. You can use your own app if you want to use push notifications on your own app because you already have one in the store. We have an SDK to do that. So you don't need to force the user to install the Authy app to do all of these. The other thing is you don't need to store any secrets. Like there is no heavy weight on your shoulders because the two-factor authentication, like all the secrets are on Authy's side, and the only thing that you have is an ID. The other thing, in case of things like push notifications, this is super safe because it's an end-to-end encryption. We know that it arrives at that device. There were no QR codes. How cool is that? Because like I don't think anyone really likes scanning QR codes. Nothing against the challenge here. All right, and the other great thing is graceful degradation. So if push isn't available, as I said, you can easily fall back to tokens and then fall back to SMS or voice, and you're good. You don't need to say, all right, do I really need to spend so much developer resources on just adding push notifications? If you already have tokens, it's really easy to add the push notifications. All right, so in summary, users are bad with passwords. Other websites are bad with passwords too. Social engineering actually works. Don't underestimate this. Not every hacker is a computer genius. They're just really good at understanding people. Two-factor authentication can be anything from push notifications to tokens or SMS. Two-factor authentication is actually for your users. So it's to keep them safe from themselves, other websites, and mainly this person who appears to be able to pick passwords out of a binary stream using tweezers. And a very important skill. All right, before we wrap up, one last thing. I would really appreciate if you could take 10 seconds to give me some feedback on this talk, either using the My Devoxx app or answering the following question via SMS. On a scale from 0 to 10, how likely is it that you would recommend this talk to a friend or a colleague? I would really appreciate this feedback because it's my first time speaking at a conference. So no worries, the number will be on the next slide too. With that, thank you everyone. My name is Dominik Kundel. I'm a developer evangelist for a company called Twilio. I'll be around for the next couple of days. It's pretty warm, so I'm not sure if I'm going to wear this jacket the whole time. So feel free to chat with me. Like there's going to be a beer downstairs, so I'm going to be there. Feel free to chat with me there. Ask me any questions. And I'll put the slides up to that GitHub later. But if you don't find them, feel free to tweet me. Cool. Yeah, running a bit under time. Do we have any questions right now? Yes. Oh. Yeah, that's true, but no. Oh, yeah, yeah, yeah. Oh, yeah, yeah. Oh, yeah, all right. Okay, cool. So yeah, I'll just repeat this because there was no mic. So thanks for that input. So there's YubiKey, which is hardware-based two-factor authentication, which is a small thing that works based on NFC and yeah, NFC, right? Oh yeah, and a hit. So you can use that as well, and that seems like a pretty good experience. But again, you're running around with an additional device, so that's why I didn't cover that. But yeah, that works definitely great as well, better than SMS. So if you want to get something like that, I think it doesn't work with iOS because, oh well, now they have NFC as well, but I'm not sure how great the API is. Yeah, so there's no SDK, so that doesn't work. So if you're not developing for iOS, feel free to look into YubiKey because that sounds pretty good as well. Any other questions? Yes. Well, I called it two-factor authentication, but you can do multi-factor, right? If you want to add additional biometrics to keep that going, go ahead. You're not stopped. Like for example, Microsoft has this JavaScript SDK that works with Edge, so you can identify, log into websites with your face. So if you want to add that to your website as well, feel free to do that. Most of these are not particularly great user experiences. If you're developing for iOS, using OneTouch, using this, what is it called, the fingerprint scanner. Touch ID, thanks for that. If you want to add that to your application, go ahead. The more factors, the better. I'm just saying, don't use one factor. Yep. Yes. Well, the soft token is just an algorithm, right? So if you want to generate this and build a small like IoT device, you can do that. Actually, the cool thing about Twilio is, about Authy is, let me switch back to, so if I go to settings, you'll see that I have accounts here, and I can switch on the Authenticator backups. And that's the cool thing that is superior over Google Authenticator. If I switch that on, and if I have multiple devices, I only need to scan once the QR code, and it propagates through the other apps. And you can have an Authy Chrome thing, and if you run that on your computer, you don't even need your phone. Like, I have that installed, you put a master password on it, and then you have that over there as well, if you forgot your phone or something. And the great thing is if you lose your phone, like that happened to a colleague of mine, or like right now, this is a demo account, right? Like, I can uninstall this, and if I reinstall this, the codes will be there again. And that's really cool, because if you ever use Google Authenticator and you switch your phone, which I recently did, and on top of that you switch your phone number, I spent a whole day just reconfiguring my my two-factor authentication, because at that point I was still using Google Authenticator and normal SMS-based, and that causes you just spending the whole day of like, where do I use two-factor authentication? So oh yeah, but that's why Authy is great. I uninstalled it now, so I can't show you anymore. But Authy actually has the possibility then to go to your devices and just kick out a device. So yeah, exactly. Yeah, but like in this case, like you can just delete a device. So if you use Authy for your two-factor authentication, and I'm not talking about like Authy also supports the Google Authenticator QR codes, but if the site actually uses Authy, that means that you will be able to revoke the access as a user as well. So if I remember that I lost my phone and I have Authy on my iPad, I can open the Authenticator app there, go to devices and say, don't use the iPhone anymore. And from that point on, the user won't be able to use that. Well, that would be kind of weird if there's a two-factor authentication website that isn't protected by two-factor authentication. But yeah, there's always a certain risk, but it's more about like protecting yourself from like easy attacks and things like social engineering. That is fair, but that's why like you have to encrypt it with an additional password, and you should not. You should not use the same password as the one that you use for your computer, obviously, because that would kind of defeat that purpose. It's just like you're not supposed to use the same password for Facebook and Twitter. Yeah, cool. Any other questions? So it seems like everyone wants beer. That's a fair thing. So once more, if you didn't grab either the phone number or my things, yeah. All right, thanks everyone.